Solve. 5 to the 7x minus 2 equals 25 to the x. With this first problem, we notice that we have a base of 5 and a base of 25, and actually we can rewrite this right-hand side so that it also has a base of 5. So we can say that this equals 5 squared raised to the x power, because 5 squared is equal to 25. And the left-hand side stays 5 to the 7x minus 2. The 5 squared then is equal to 25, but when you have something with an exponent raised to another exponent, then you can multiply these exponents. So now we have 5 to the 7x minus 2 equals 5 to the 2x. And now, because we have the like bases, then absolutely these exponents must be equal. That is, 7x minus 2 must equal 2x. So I'll write that down. I'm going to write it out down up here. 7x minus 2 equals 2x. Let's subtract 2x from each side, and you get 5x minus 2 equals 0. Add 2 to each side, and you get 5x equals 2. Divide by 5, and you get x equals 2/5. So we solved that equation. That is, if you plugged in 2/5 in for x, it would make this equation true. The next one, we have 4 equals 3.2 raised to the power of x over 2. To solve for this unknown exponent, we can use logarithms. So specifically, what I like to use is the natural log. So I'm going to say the natural log of 4 equals the natural log of 3.2 raised to the x over 2. And you can do that because if each side is equal to each other, then the natural log of each side would still be equal to each other. That's why that's a legal move there. By properties of logarithms, we can also say that this x over 2 can be put in front or multiplied by this logarithm. So I'll rewrite that as the natural log of 4 equals x over 2 multiplied by the natural log of 3.2. Now what we're going to do is start to take some steps to isolate this x. The first thing I'm going to do is divide each side by the natural log of 3.2. And I'll just write that down so we're all on the same page of what's happening here. And as a result, I get the natural log of 4 over the natural log of 3.2 equals x over 2. I didn't evaluate this yet, and the reason is because I don't want to hang on to a lot of decimal places that I would have to round, and I don't want to round too early. Certainly you can do that though. There's nothing wrong with just typing in and evaluating natural log of 4 and the natural log of 3.2 and then just dividing those and to have some number there. But I'm going to show it in another way that you can just type in the whole thing at once into your calculator. Let's multiply everything by 2 so that we can get rid of the fraction, get rid of this denominator. So each side will be multiplied by 2, and then what you would type into your calculator would be 2 times the natural log of 4 divided by the natural log of 3.2. And I know the graphing calculators makes you put the parentheses there, and you'll need to definitely, here's a big deal here, definitely close the parentheses on the numerator before you then divide by another logarithm, because if you don't, you're just going to get an incorrect answer. Alright, and to write the answer, x equals all of that stuff. X equals, rounding here, 2.3 0.84, so approximately equal to, because we did round at that third decimal place. So two different ways of solving for exponents.